All right, let's dig in. We got we got halfway through the event. Well, once we finish today's, we'll be halfway through, right? We'll have 12 out of the 24 stars we need to collect, and then the 25th star is always a freebie once you get the previous 24. So I count day 12 completion as being halfway through. All right, Advent of Code 2023, day 12. Hot springs. Oh, we finally made it to the hot springs that have been foreshadowed for the past few days. You finally reached the hot springs. You can see steam rising from secluded areas attached to primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen, which is hot springs in Japanese, right? Hot springs are next door. You look in the direction the researcher is pointing and suddenly notice massive metal helixes towering overhead. This way! Yeah, so that was the pun, the anticipated pun. It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate into a small administrative building. Oh, it brings you to the hot springs today. Sorry, they're not very hot right now. We're having a lava shortage at the moment. You asked about the missing machine parts for Desert Island. Oh, all of Gear Island is currently offline. Nothing is being manufactured at the moment, not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Is that true? I thought springs. Okay. When you heat up metal, it doesn't become springy. It becomes less springy. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you there. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged. Your puzzle input are also damaged. Their condition records. Ah, I see. The condition records of which springs are down. Okay. You'll need to help them repair the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it's operational or damaged. This is part of the condition records that itself is damaged. For some springs, it's simply unknown whether the spring is operational or damaged. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. List always accounts for every damaged spring in each. Okay, so this is like one line. Yeah, I see all the question marks here. One line nonograms. This does seem very difficult to write a program for because I don't know. I've never written a nonogram solver. This has one possibility. This one has one possibility. The one could be here or here, right? If I'm reading this correctly. In the first line, question mark, dot, hash, hash, hash. Exactly one way to separate groups, right? And this one's more interesting because, right, okay. I think I understand what's being asked of us. Right, and we could just loop through all the possibilities. But I bet you there's a more efficient way to do the solution than just looping over all the possibilities. Like you could create a group of things that contain question marks and hashes, right? Like for example, here, we don't want to check every single possibility, right? Because that would mean shifting these two groups along, but these two groups don't need to be shifted. They're fixed in place. The same with this. Here, it's a little more wacky because you need to be able to determine which ones are dots. I don't know. I don't know a good way. I don't know a good approach. We can try the brute force method and see what works. See how far that gets us. Oops, I messed up this thing here. I did that once before. So 12, 12, mut day 12. And we have to create this. Come on. 23, 12. There we go. All right, so first things first, let's get the input. Oops. And then we can create, wow. Let lines equals AOC lib. Nasila says you can brute force part 1. Okay. I guess brute force doesn't work for part 2. Oh, I didn't get the input yet. Let's do that. All right, there's 1,000 lines. I mean, looking at this, it's obvious, right? 111,511. So here's the 1, 1, 1, and then the 5 is either this group of 5 here with a 1 and a 1 arranged somewhere this way, or this group of 5 here arranged with the 1 and 1 only in one location, right? So is there a way I can take my visual inspection and brain manipulation of that pattern and convert that into code? Problem with brute force is I have to actually come up with a way to generate all the patterns, which is not going to be, I don't think that's going to be easy. All right, let's make a spring type. Which contains a pattern. What's the best way to store the pattern? Vec of chars, maybe? And then the sizes, which would just be a vec of usize. And then we can parse all those for line in lines iter. Let pattern nums equals line split once on the space, and let let's say sizes, yeah, equals nums dot split on comma val parse unwrap collect into a vec, and then up here we'll just have a list of springs, vec spring, right? And then down here we can say let pattern equals pattern chars collect. I think if I do the push, I don't think I need to do this, right? I can say spring self springs push spring pattern sizes. Can I do that? Yeah, it like that. And there should be 1,000 of those. Self springs len 1,000. Perfect. All right, so parsing is done. Now comes the hard part. How are we going to walk our way across this thing without blowing up? Because Nice Law said in chat, if you can brute force part 1, leaving open the assumption from me that part 2 is not brute forceable. So whatever brute force, whatever part 2 turns out to be, it's going to be a lot more complex. Which means that we want to come up with a way to not brute force it, because why waste time brute forcing it if that's not going to work for part 2. The only reason to do it is if we're just trying to get that part 1 done and then spend time doing part 2. Would doing a brute force on part 1 help us to understand what to do to not brute force part 2? I don't think so. I mean, brute forcing is just doing this, right? And this is just a matter of Is there a way we can reduce it down to something that we can come up with a pattern for? Let's see. Is there something in which we can store previous results somehow? Code Monk says you're going to need a really big computer for part 2. Yeah, if we do a brute force, right? I'm just hesitating because, you know, brute forcing it is. It would be taking each of the sizes, right? We have all the sizes in these numbers here. For example, 113, and then putting and just creating this hash, right? So a hash here, and then 3 hashes here, and say, okay, does that match? If that doesn't match, then, you know, move this down by 1 and see if that matches. Maybe what we can do is we can somehow do the restricted search. Maybe that would help. Although it wouldn't help with this case. It would help with this case to say, okay, well, we have a run of things here that we can stick stuff in. Right, we could search forward for the first question mark or hash when we're looking to put down the hashes. And then say, okay, we'll put it there and then skip one. That kind of lends itself to thinking about how we could do it in a non-brute force way, right? We could say, okay, we have this pattern, and we're looking to place down 1. We're going to start at the beginning. We'll put down a hash, and then we know it's a 1, so we'll skip 1, and then see if we can put down 6. If we can't put down 6, then we'll move to the next thing, and we'll see if we can put down 6 there. And if not, we move to the next thing and see if we can put down 6. Okay, now we can put down 6. Let's try putting 5 here. Would that be a non-brute forcey way to do it, right? Rather than trying to generate every single pattern and seeing which one matches. All right, let's get back to day 12 because it's just bugging me that I don't have it solved. I think I have an idea of what I want to do. So the first thing I want to do is blow away all of my old code. Let's just take all of this out because this is just painful to look at and painful to try to debug and painful to delete it. So we can do this and this. Oh, I should have renamed them. We'll put them back. I renamed them yesterday. Right. And now, I think what I want to do is extract this. Let's do what I just said I would do and implement from stir for spring, right? We're not going to get any errors, so we don't care about that. And it's just this. Right? And then this. this, right? And it's just okay of this. All right. So now I should be able to say line parse unwrap, right? And it should just work. Oh, I have to switch this over to the correct day. Hang on. This is S. Okay. Because right now it's, I don't know what it's still running day 14. Yeah, so let's switch this over to day, oops, go here, source main. And I'm going to force it to run 12. Oh, it's going to complain if I do that. Okay, let's just put 12 here and 14 here. Oops, 14. There we go. And run. Yeah, now it's running day 12. Okay. That's another thing I need to improve, is being able to select that. Okay, the reason I want to do that was because I wanted to actually, instead of having this thing here, I should be able to say spring, and then give it a string. And this is what I want to do, is I want to copy all these guys, this box here, and make a test, one test for each of them. Right, and they're all going to start with let spring equals quote, and then you're going to do parse unwrap on each one of those, and then I'll write a test case for each one, right, which should hopefully simplify things. Let's get the answers, and then we'll slowly work on getting the test cases working. Right, we'll just call it score. We can do that. Test 3. Test 3 should have 1. Spring score. Right. Test 4. Test 5. And test, nope, like this. Test 6. So we put that here. Put that here, and put that there, and now we're expecting 1 4 1 1, then 4, and then 10, right? Spring score. There. And now if we run the test, it should fail because score doesn't exist. Okay, so let's add a score function. It just returns nothing now. Get rid of this thing here. These sizes are what? Are they U sizes? They are U size. So let's just do that for now. Good. Okay. Now I think I know what I want to do. And this is my idea, is that I'm going to try my best to do this recursively. What I'm going to do is going to create a function, doScore, which takes in a pattern, and we have vec of chars. So we're going to do that this way, char, and sizes usize, and returns a usize. And this is going to be the recursive function that will start off here. Actually, we don't need self on this, right? So here we just call doScore self pattern and self sizes. This now is just going to match on the first character and decide what to do. We do need to make sure that there are characters left. So let's see, if Pat is empty and sizes is empty, then we've reached a finishing condition. I guess I should split this up just in case. If sizes is empty, then we've reached a successful end case if there's nothing left in the pattern, or there are no hashes left in the pattern. So I can say return not pat iter any x such that x is equal to a hash. Right? So if we find a hash, then this any is true, and so we turn it to false, which is 0 in C, but not in Rust as usize. Right? If we don't find any hashes, then this is false. This becomes true, which means we found a success. Why not pat contains? Because I didn't think of that. Can you do that? Does that exist on? Yeah. Okay. Good. Okay. So if sizes is empty, then we return here. So we know that sizes is not empty once we get here. If the pattern is empty, but the sizes is not empty, then we failed. Actually, we can make this more specific, right? Scoop says reference to, yeah, I tend to ignore, even though this is nice and bright and red here, right? I tend to ignore it. I don't know why. Let min remaining is equal to sizes.iter.sum usize plus sizes len minus 1. So we need this many characters at least remaining. So if the pattern's length is less than the minimum remaining, then we cannot fit the remaining pattern in there. Okay, so now we're going to check. We have, it's either going to be a dot, or it's going to be a hash, or it's going to be a question mark. Those are the three possibilities. Anything else is panic. Invalid char in input. Right? And then what this will do, this will return how many matches we get out of that. How does that sound? Oh, I forgot I wasn't in a loop. Consider using the associated function. Oh, right, self. Do score. All right, is there anything else I'm missing from here? All right, so if we find a dot, then we're going to just move one more down. So it's going to be do score pat of 1 and sizes. Right? That should be easy. Math Player 9, thank you for the follow. Self. There. A hash. This one's a little complicated. I'm going to separate it out into its own function. Do a hash. Pat. Char. Sizes. Usize. Usize. So if we're treating the first character as a hash, we have to make sure that sizes of 0 characters within the pattern does not contain a dot, right? It can contain other hashes and contain question marks, but no dot. So we can say if pat of 0 dot dot sizes of 0 contains a dot, then we'll return 0. What other cases are there that would make this work? If pat len is equal to sizes of 0, that means we've reached the end of the pattern, and if there are no more sizes after that, then we can return 1. We say we found a match. Maybe I should check the length first. If pat len is less than sizes of 0, then we failed. I guess I can make this an OR condition, right? Oh, I need to do that. Right? If we have less than, because this short circuits, right? So if we have less than the number of characters we need for this, then we're done. Or if there's a dot in there somewhere, then we're done. So now we know that pattern length is equal to size or greater than size. If it's equal to size and we have 1, oh, we can do that here, right? We can say return sizes len equals 1 as usize, right? Just like that. So now we have the case where pattern length is longer than sizes of 0. We have to make sure that there's no hash after the pattern, right? For example, here, we have to make sure that this doesn't match the 3 because there's a hash mark after it. So we have to say if pat of sizes of 0 plus 1 is equal to a hash, then we did not find a match. Otherwise, we can just call back on score, right? Do score self, do score pat of sizes of 0 plus 1 dot dot, and remove the first one from sizes. Right? I think that's do hash. Pat sizes. A question mark is going to be either one. Self do score pat 1 dot dot sizes plus self do hash pat sizes. I think this is close to what I want. This is what's been bouncing around my brain. Let's see if it works on any of the test stuff. It failed miserably. We're going out of bounds all over the place. So let's take a look at that problem first, line 87. Wait a minute. So how are we getting here? Pattern length is not equal to sizes, and pattern length is not less than sizes. So it has to be greater than sizes, right? So why doesn't this work? I guess I'm confused. Pat len greater than sizes of 0. No, we're still failing right there. Here we go with the print testing. Pat equals this, size equals this. Pat len sizes of 0. Pattern length is 7 and the size is 6. So I can just add one here. No. I just want to be able to check the one after it. Let me print out the pattern itself. Maybe that's what's confusing me here. Size is 3, right? So we're trying to say size 4. Which is wrong. 1, 2, 3, 4. Okay, we don't want to actually increment by 1 here. Okay, maybe that's the problem. Full stop slash. Thank you for the follow. Tommy, guten Morgen. Oops. Like that. Ooh, wow. Okay, so all the test passes. So I guess what was rattling in my brain kind of works. Let's see if this works. Let's see if it works on the test input. Oh, I mean, it does, right? Let's see if it works on the real input. Which means hitting run after I update part 1. We don't want self springs len. I'm starting to get excited. This is scary. Self springs map score sum usize. I can't do that. Spring score iter run 7771. Is that worth trying? Hey, finally! Freaking finally! I spent 2 hours. I spent 2 hours on this 2 days ago. And then I had 2 days to think about what I did wrong and why I should be punished. But this is making me happy now. Oh, God, that was so painful. Git add source git commit -m 2023 day 12 part 1 finally. After all that mess I went through. I wonder what the ideal solution to this would be, because I mean this seems pretty clean, right? I mean it can fit all on in one window. But I'm sure it could be better. Mohad says, did you use recursion? I did, yes. So do score calls do score, do hash calls do hash. Sorry, do hash calls do score. So there's a lot of recursion. So let's see what part 2 is. As you look out at the field of springs, you feel like there are way more springs than the conditioned records list. When you examine the records, you discover they're actually folded up this whole time. To unfold the records on each row, replace the list of spring condition with 5 copies of itself separated by question mark, and replace the list of contiguous groups of damaged spring with 5 copies of itself separated by comma. So this row, dot hash, would become dot hash question mark, dot hash question mark. Okay, repeated 5 times. Oh, there's no question mark at the end. It's just, okay, so it's just like a join. Okay, and then 5 ones, comma together. And then we have test input for part 2. Okay. So what we can do is create a part 2 score, which generates a usize. And then I can generate a pattern by duplicating these guys and generating a score. The only thing is that I've got a feeling this might be a, well, we'll see. We'll see what happens. So for in 0.5, 0.4 pattern extend self pattern iter chain like that, and then do that again without the chain, and then we'll do the same thing for sizes, but we can go to 5 because we don't have to put anything in between, right? Sizes equals, oh, sizes extend self sizes iter, right? And then we need to calculate the score on that. Oh, I didn't, yeah, I can just stick it here, pattern sizes. Okay. Doesn't like this. Why not? Expected reference. Okay. Oh, how did I end up with 2? Mutt. Okay, so now part 2 is just calling that with score part 2. Score part 2. Sum U size. Computing. Yeah, this is computing. I think release. Let's see how slow it's going. Because I might need to do caching. Where's score part 2? Here it is. So we'll just print out self pattern iter collect string. It gotten 3 of them done. Oh, it's getting there. How many are there again? There are like 1,000, right? All right. So what I'll do is I'll let this run, and what we'll do is we'll just add a cache to it and see what happens. How do we want to add a cache to this? We can do is pass in a map, right? Map what? And we'll just cache it in terms of pattern and sizes, and then we'll store the return value from here in it. So it'll be a hash map of a tuple of vec char vec usize. Let me make this a separate type. Type cache is equal to hash map vec char vec usize, and it's going to be a usize, right? And we have to pull this in. All right, so that'll be our cache, and we'll create a new cache here. Let mut cache equals. Can I do cache new or have to do hash map new, right? And then do score will get the cache. And I'll have to actually do it for part 1 as well. Although we didn't need a cache for part 1. It's going, it's going. Let's see if we're racing this thing now, right? And so we'll just stick this cache in here. Like that. And we can say if cache let sum result is equal to cache get. Wizard says you could use the lengths of the vectors as a key. Okay. I'll try that next. Let me try it this way because this is what's in my brain. Pat to vec. Sizes to vec. Because they're slices. You have to convert them to vecs. Right? Return result. Expected comma. Why do we expect a comma? Oh, this has to be a reference, right? Expected one argument. There we go. Okay. And then we actually have to store it. Let result equals this. And say cache insert pat to vec sizes to vec result and return result. We have to pass in the cache here. We're going to have to pass it in here as well because it also calls. If I end up with lifetime issues, I'm going to cry. What do we got? Consider dereferencing the borrow. Okay. It built. First try. Misery said, lots of wasteful allocate. Yeah, I'm just trying to get the answer, man. I'm just trying to get the answer. It's been 2 days. It's been gnawing at me. What's the line from The Wrath of Khan? He tasks me. This tasks me. Cargo run. Release. Okay. I think that finished a little bit faster than the other one. Who knows if it's right? I'm afraid because I don't know how to debug it. Yes. Okay. Thank goodness. That is such a relief. One of my personal times. Oh, that's not bad. It's not, in terms of people solving it, I mean, it's in the same ballpark as my other ones, right? I'm going to leave this running while I optimize this. Okay, so you're saying, Mister, we could just do, let me commit this. 2023, day 12, part 2. Thank God.